If two vectors are perpendicular, their dot product is always 0. Vectors can be multiplied in two ways. One is scalar product, that is called as also dot product, and another one is the vector product or cross product. What is the magnitude of y? Since this is a unit vector, magnitude of unit vector is always 1. Vector A is unit vector. Then modulus of vector A is 1, or the magnitude of vector A is 1. Hello everyone, a warm welcome to one and all. This is Ashruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. In this session, we are going to study about the product of vectors, and one of the type of the product of the vectors, that is the scalar product of vectors. So we have two methods of multiplying the vectors, and the one method is called as scalar or also called as the dot product, and vector or cross product. So vectors can be multiplied in two ways. One is scalar product, that is called as also dot product, and another one is the vector product or cross product. Let's see what is the definitions of scalar product says. Suppose if we have two vectors, vector A and vector B, then the dot product of the vectors is denoted by vector A dot vector B. Since the symbol dot is used there, we call this product as dot product. And how it is defined? Vector A dot vector B is equal to modulus of vector A modulus of vector B into cos theta. So this is how we are going to multiply the vectors in terms of scalar product. Now, thus what we have, A dot B is equal to AB cos theta. We can also write this as AB cos theta, where A and B defines the magnitude of vector A, magnitude of vector B. Now, from this formula, we have the following observation. So, the very first one is vector A dot vector B is a real number. It is always a scalar quantity. So, here you can't define the direction of this vector. So, therefore, the product of this vector is just a scalar quantity. You will only get the numerical value without I, j, k. So, therefore, it's clearly a scalar quantity. Now, since we have in the formula, that is vector A dot vector B is equal to AB cos theta or mod A mod B cos theta. Suppose angle between the two vector is 90 degree. That is, one vector is perpendicular to other vector. If there is a 90 degree, what is cos 90? It is 0. Then A dot B is equal to 0. If cos theta is 0, AB into 0 becomes 0. So, therefore, the dot product becomes 0. So, therefore, A dot B is equal to 0. That means the two vectors are perpendicular. Now, if theta is equal to 0 degree, so that is, it is vector A and vector B. Both lie or both coincide. Then the angle between them is 0 degree. So, cos 0 is 1. Then the dot product of vector is just the magnitude of the vector, that is the product of their magnitudes. We can just write it as A into B also. So, A dot B here is just AB. So, in particular, here A dot B, if here vector B is equal to vector A, then what happens? A dot A. So, that is vector A dot vector A is nothing but magnitude of A, that is equal to A into A, which is equal to A square. So, in general, A dot A is nothing but A square. Next, if I, j, k or the unit vector along OX, OY, OZ, they are mutually perpendicular to each other. We know that in any three-dimensional axis, that is X, Y and Z, so I, j, k are also mutually perpendicular to each other. They are the unit vector which are mutually perpendicular on the plane OX, OY and OZ. Then what is the dot product of those vector? So here I dot I. So we know that here A dot A is nothing but A square. So I dot I is nothing but I square. What is the magnitude of I? Since this is a unit vector, magnitude of unit vector is always 1. So therefore, I dot I is nothing but 1. Similarly, j dot j is 1. K dot k is also 1 because I square, j square, k square is nothing but 1 square, which is equal to 1 because they are unit vector. Now, what is I dot j? We know that if this is vector I, this is vector j and this is vector k, I dot j is perpendicular to each other. What happens when two vectors are perpendicular? Their dot product becomes 0. So therefore, I dot j is 0. Similarly, j dot k as well as k dot I are 0 because they are mutually perpendicular. So thus, what we can say, if two vectors are perpendicular, their dot product is always 0. Next, angle between any two vectors can be written as cos theta is equal to a dot b divided by modulus of vector a and modulus of vector b, or we can also write it as vector a dot vector b divided by a into b, where a and b represents again the magnitude of vector a. Thus cos theta can be written as a dot b by ab. Now, so if theta is equal to 0, that is angle between them is 0, that means vector A and vector B are collinear, that is they are parallel to each other. They may coincide or they are parallel to each other, so that the angle between them is 0. So thus cos theta becomes 0 means angle between them is also 0. Now again, if theta is equal to pi by 2, then the vectors are perpendicular. If we get the value of theta as pi by 2, that means the vectors are perpendicular. Thus, what we can conclude, in a dot product or a dot b, if a dot b is 0, then we can say the vectors are perpendicular. If angle between them is pi by 2, then that is also nothing but they are perpendicular. If angle between them is 0, that is if cos theta is 0, then we can say the two vectors are collinear. Next, we come across component form of a scalar product. Now, let vector A is a1i, a2j, a3k and b is equal to b1i, b2j, b3k. Then how to multiply the two vectors in terms of dot product? So here a dot b is given by a1 b1 plus a2 b2, a3 b3. You can also verify this. If I write a dot b, what happens here? A1 into B1. So, A1, B1, we have I dot I. Next, we have A1, B2, I, J. Next, we have A1, B3, I, K. Plus, next we have A2, B1, I, J. A2, B2, J dot J. Next we have A2, B3, J dot K plus next we have A3, B1, I and here we have K plus A3, B2, so K dot J and A3, B3, K dot K. So we know that I dot I is nothing but 1. So J dot J is nothing but K dot K is nothing but 1 because they are the unit vector. We know that vector A dot vector A is nothing but A square and I dot I is nothing but I square. Since I is the unit vector, it is magnitude is 1, so 1 square is 1. So if it is 1, then I can write A1, B1. What about I dot J? We know I, J, K are perpendicular to each other. If vectors are perpendicular, then their dot product is 0. So I dot J becomes 0. 0 into A1, B2 becomes 0. So this is equal to 0. So this is also equal to 0. I dot J is 0. Then we have A2, B2 because J dot J is J square, which is nothing but 1. Then J dot K is 0, I dot K is 0, K dot J is 0 and A3, B3 is K into K whose value is 1. So therefore it is A3 into B3. So thus you can see this is how we will get the dot product of any two vectors. So Whenever any component of two vectors are given, multiply I component with I component plus j component with j component plus k component with k component. So that is what a1 b1 plus a2 b2 plus a3 b3, which is the dot product of the given vectors. Let's move on to the problems now. If vector A is equal to I plus j plus k, vector B is equal to I minus j plus k, then find A dot B. What is A dot B? Now, A dot B is equal to A1 B1 plus A2 B2 plus A3 B3. So, what is A1, A2, A3? The components of vector A, that is 1, 1, 1. B1, B2, B3 is 1 minus 1, 1. So, A1, B1, 1 into 1 plus A2 is 1, B2 is minus 1. A3 is 1 and B3 is also 1. So, we get 1 minus 1 plus 1. So, A dot B is 1. So, I already said it's a scalar quantity. So, therefore, you will get A dot B in terms of numericals. Next, find the angle between the two vectors A and B with magnitudes root 3 and 2 respectively, having A dot B is equal to root 6. Now, we know that cos theta is equal to A dot B divided by magnitude of A, magnitude of B. Now, they have given A dot B is equal to root 6. So, here the magnitudes of vector A and B is given. So, that is magnitude of A is root 3 and B is 2. So, when you cancel this, root 6. So, you will get it as root 2 divided by 2. So, which is nothing but 1 by root 2. So, now we have cos theta is equal to 1 by root 2. So, theta can be written as cos inverse of 1 by root 2. So, for what values of theta you will get cos as 1 by root 2? Pi by 4. So, therefore, theta is equal to pi by 4, or we can say it's a 45 degree. So, therefore, the angle between the two vectors is pi by 4. Next, find the angle between the two vectors I minus 2j plus 3k and 3i minus 2j plus k. So, here we need to find out the dot product, their magnitudes to find cos theta. So, let vector A is equal to I minus 2j plus 3k and vector B is equal to 3i minus 2j plus k. So, let me find A dot B first. A dot B is, here we have I into I component, means here we have 1 into 3 plus j components minus 2 into minus 2 plus k components 3 into 1. So, we will get 3 plus 4 plus 3. So, therefore, A dot B is equal to 10 we have. Now, let's find out magnitude of vector A. Magnitude of vector A is square root of 1 square plus minus 2 whole square plus 3 square, which is equal to 9, 10 and root 14. Next, we will calculate magnitude of vector B, which is 3 square plus minus 2 square plus 1. Again, it is clearly 9, 10, root 14. So, now we have A dot B as well as magnitude A, magnitude B. So, what is the angle between two vector? Cos theta is equal to A dot B divided by magnitude of A by magnitude of B. So, which is nothing but 10 divided by root 14 into root 14, which is nothing but 10 by 14 or 5 by 7. So, when you simplify it, you will get 5 by 7. We have cos theta is equal to 5 by 7. So, therefore, what is theta? Theta is equal to cos inverse of 5 by 7. So this is the value. Next, find the angle between the vectors. Vector A is equal to I plus j minus k and vector B is equal to I plus j plus k. Again, we need to find out magnitude of A, magnitude of B and A dot B. So let's find out A dot B. So first I components we will multiply. So 1 into 1 plus 1 into 1 plus minus 1 into 1. So we have 1 plus 1 minus 1. So we have A dot B is equal to 1. Now magnitude of vector A, clearly you can see it is square root of 1 square plus 1 square, 1 square plus 1 square plus minus 1 whole square, which is equal to root 3. Similarly, magnitude of vector B is again 1 square plus 1 square plus 1 square under the square root, which is equal to root 3. So therefore, now angle between the two vectors is cos theta is equal to A dot B divided by magnitude of A, magnitude of B. Now A dot B we got it as 1. Denominator we have root 3 into root 3, which is 1 by 3. So cos theta is 1 by 3. What is theta? Theta is cos inverse of 1 by 3. So therefore, this is the angle between the two vectors, vector A and vector B. Next, find modulus x if for a unit vector A, x minus A dot x plus A is equal to 12. So we know that x minus A, x plus A. So A plus B, A minus B can be written as A square minus B square. Now we are multiplying two vectors. We can also use the dot product form or we can directly write x minus A dot x plus A is equal to 12. Use the formula A minus B, A plus B. Then this becomes modulus of vector A square minus modulus of vector A square is equal to 12. Now they have given a unit vector A. So vector A is unit vector. Then modulus of vector A is 1 or the magnitude of vector A is 1. So therefore, here it becomes 1. Now magnitude of vector X is equal to 12 plus 1, which is equal to 13. So therefore, magnitude of vector X is square root of 13. Since we are talking about the magnitude, which is nothing but length, no need to write plus or minus root 13. It is always positive. So just write root 13. Next, if vector A is a unit vector and x minus A dot x plus A is equal to 8, find magnitude of vector x. So now again using the same formula, vector x minus vector A dot vector x plus vector A is equal to 8, which becomes magnitude of vector x square minus magnitude of vector A square is equal to 8. Given vector A is unit vector, so therefore here the magnitude of vector A is 1. 1 square is 1, so 8. So magnitude of vector x square is equal to minus 1 when it goes there, it becomes 8 plus 1, which is 9. Now if you want magnitude of vector x, it is root 9. So therefore take only the positive quantity, thus magnitude of vector x is 3. Next, find magnitude of vector A if vector A minus B, vector A plus B is equal to 8 and magnitude of vector A is 8 times magnitude of vector B. Again here using the same A minus B, A plus B can be written as magnitude of vector A square minus magnitude of vector B square is equal to 8. Given A is 8 times B, so therefore here it is 8 square magnitude of vector B whole square minus magnitude of vector B square is equal to 8. So here it is 64. If I take magnitude of vector B as common here, whole square as a common, I'll get 64 minus 1, which is equal to 8. So magnitude of vector B square is equal to 8 divided by 63. So therefore, magnitude of vector B is square root of 8 can be written as 2 root 2 divided by root 63. So this is magnitude of vector B. Now we have magnitude of vector A as 8 times magnitude of vector B. So here we have 2. So this is now 8 into 2 root 2 divided by root 63. So therefore, magnitude of vector A is 16 root 2 divided by root 63. So this is the magnitude of vector A and vector B. Next, if magnitude of vector A plus vector B, magnitude of vector A minus vector B are equal, then prove that vector A and vector B are perpendicular. Now we have magnitude of vector A plus vector B and magnitude of vector A minus vector B are equal. Squaring on both sides, we will get square on both sides. Now use the formula A plus B whole square and A minus B whole square. Then here it becomes magnitude of vector A square plus magnitude of vector B square plus 2 times vector A dot vector B. And on the right hand side we get again A square plus B square minus 2 times A dot B. So since here how I have written A plus B means first we will take vector A into vector A. So A dot A. So vector A dot vector A is nothing but A square, which can also be written as magnitude of A square. So A is nothing but magnitude of A here. So when you are multiplying the dot product of same vector, it is nothing but mod A square. So that is why again B dot B I have taken as mod B square. Now coming towards A dot B, B dot A, since they are one and the same here, so I can write 2 times A dot B. So here also multiplying A minus B 2 times, A dot A becomes mod A square, B dot B becomes mod B square, 2AB becomes minus 2 times A dot B. Now here we can cancel magnitude of A and magnitude of B square on both sides. Here we have 2 times A dot B. I'll shift minus 2AB to the left hand side. Again it is 2 times A dot B. So on the RHS the value is 0, which is 4 times A dot B, which is equal to 0. So this implies 4 cannot be equal to 0, but I can write A dot B is equal to 0. So we have here the dot product of the two vectors is 0. When we say the dot product of two vectors are 0, they are 0 only when the two vectors are perpendicular. So therefore I can write vector A is perpendicular to vector B. That is when the angle between the two vectors is 90 degree. Then what we can say, vector A dot vector B is always 0. So thus when two vectors are perpendicular, their dot product is 0. Now we have shown that the dot product of two vectors are 0. That implies the vectors are perpendicular. We'll meet you in the next session. Until then, keep watching, keep learning, keep exploring. Thank you.